Again, this is the steps for graphing a rational function. Yes, ma'am. Yeah. So I'm in polyester. I'm sweating right now. Yeah. Sorry. There's a blanket too. I'm not going to turn up the AC though, so you can grab a blanket. That's why I have them. This is about as cold as it used to be my last year's class. All the time. Remember that, Val? It's cold. Freezing all the time. So grab a blanket. Grab a blanket. Really, they're going to help you. I swear it looks perfect. Yeah. It's freezing all the time in there. Yeah, we should only have 2 homework problems today. I'm going to do 2 of them with you already. I'm going to try to ask you guys to graph the slant ones, at least one slant one, just so you guys can test it out and see how well you guys do. It's no different than what these are doing. I just like them because they're requiring you to do a little bit of synthetic division or long division with it. But the problems are going to be nice. So, you know, yeah, don't freak out if you don't get that. But you guys only have 2 problems today. You know, spend time with your families on Halloween. It's my dad's birthday today too, so I'm gonna go spend time with him. Taking my daughter trick or treating. You know, she's gonna be a little poodle skirt, little 60s little greaser girl. Yeah. Huh? That's yours? Yeah, stay warm. Don't get sick. I want to see you guys on Wednesday. Don't have too much candy. Don't eat candy that's already open. That's a no-no. Don't do that. Okay. Are we good to go? That's it. No. Here we go. Let's look at graphing rational expressions. If we followed this every time, we're going to be able to graph this pretty accurately. So let's take a look at this one. So copy down that problem on your guys' paper. I've given you guys a graph paper to look like, what it's going to look like. It's on, is it only one side? No, it's on be on a separate sheet of paper. This one you're going to do on the handout now. You guys have the handout for this, so you guys don't have to copy down a lot. Okay, this is now in the handout. The stuff I wanted you to write down before is what you're going to use to help you graph these things. No, you won't. Not on the handout. That was a separate sheet. Separate sheet was the rules, the how we're going to do it. The handout is separate. Yeah. We're going to show the work for this. That's what the handout's for. Now, what we're going to look at is doing these 5 steps. And again, I can't ask you to be accurate with these, but I want you guys to be close to accurate. Okay? We should be able to understand some of our stuff in here. Looking at this, is our polynomial factored from the numerator and denominator? Can't reduce it down any further than what it is, so we don't have to worry about that. So our factor is our first case. We don't have to do it. Wow, mess it up for me. Don't fail. Okay. Give me a second. No, Sarah has to cancel. Okay, here we go. A lot better. There it is. Now, our polynomial is already factored, so we don't have to worry about that. Numerator and denominator are already done. We got to be able to solve for the intercepts. The intercepts are going to be key points. They're easy to find for us. They're going to help us determine several things. For the x-intercept, we want to set y is equal to 0. And for the y-intercept, we're going to set x equal to 0. On the handout. On the handout. I'm trying to do a lot of them for you guys, so at least you have examples so you don't have to keep on copying everything down. Now, if we set the y equal to 0, we're going to get this. Y is equal to 7 over x plus 4. What happens when you multiply both sides by x plus 4? What do we get? 0 equals 7. Is this good or bad? This is bad. So in this case, we have no x-intercept. That means it's not going to cross the x-intercept. So we have no points we can put on this line, on the x line. If we look at the x-intercept or the y-intercept, we're going to set y is equal to, or x equal to 0. This is going to give us 7 over 0 plus 4. If we're going to simplify that, we're going to get y is equal to 7 over 4. This means I have a y-intercept at 7 over 4. Kind of give me rough estimates of these. 7 divided by 4, or 7 over 4, is approximately 1.75. So I'm going to graph that point over 1.75, so almost a 2. So that's my first point. Can I graph that already? Yeah. Does it help me graph the actual function? No. We got to do a little bit more stuff to that. X and Y intercepts, I'm going to ask you for them. Okay? You got to be able to do those. The next one we're going to look at, sorry? What's up? What did I ask you? It could be a decimal. I'm not going to look at like, oh, you're not at 0.75, you're at 0.5. I'm marking you off. I'm looking for decent numbers. Okay? Our vertical asymptote comes from our bottom denominator. X plus 4 is going to be equal to 0. That means x is going to be what? Negative 4. This gives me my vertical line for my asymptote at negative 4. 1, 2, 3. 1, 2, 3. My vertical line there. If I'm graphing the next one, horizontal deals with our exponent, our leading degree. What is our leading degree for this? We are pretty much x to the 0 power over x to the 1. So what do I have? Small to large, which means what? Y is going to be equal to 0, which should make sense because we don't have an x-intercept. That means a horizontal line through my x-axis. So I have my horizontal and vertical asymptotes. The last thing we're going to do, we don't have a slant with this one, so I can automatically eliminate the slant. Now we got to be able to test several points. Let's test several points. Let's test them near the intersection of our horizontal and vertical lines. In this case, I'm going to try negative 3.
How do you know which ones to try?
Try them near the intersections of these. Okay? If you're looking at these, we're going to try near these. So I'll try negative 1. I'll try negative 3 to see if it's on the top or bottom of here. And I'm going to try, let's see, this is 4. We'll try 5. We'll try 5 and a little bit over. We'll see what those look like. Okay? So you just want to try these ones out. Try them. Okay, we already have one for our intercept, so I know it has to be on the top of that. Okay, so in this case, let's try -3. And then we'll try 5 to be on the right. So we're going to go further down here to see what that's going to give me.
Are we just like guessing on points?
We're guessing on points. You can guess any points you want. I think I'm going to give you the points I want you to guess, though, because I want you to give me good values. And all you really have to do is plug in. If you plug those in, you know, so let's say I give you these ones. Let's say -3, -5, and 1, 2, 3, 4, -5, and we'll say -8. Let's say I wanted you to try these problems out. What would these look like if you tried these out for me? Now, we want to be able to graph this. I'm going to cheat and just go to the table. If you were to plug these into the actual equation, at -3, you're going to get what? 7. At 5, you're going to get what? 5, you're going to get 0.7. At -5, you're going to get what? I'm plugging these in. Yes, I'm plugging my x's into my bottom equation. You're just plugging it in. Do I need to show you guys? Do I need to show you guys? Like, this is just direct plugging in, guys. We're going to get -7, and at -8, what are we going to get? 1.75. So if I plot these points, back 3, up 7, 1, 2, 3, 4, 5, 6, 7's here. I have my intercept here. At 5, 1, 2, 3, 4, 5, I'm going to go up 0.7. So right there, looking at these, we can connect them now. So that's going to be the top one. Going back -5, I'm going to go down 7, so they're going to be down way down here. At -8, it's going to be at 1, 5, 6, 7, 8. It's going to be at -1.75. So I'm going to like super over exaggerate these so you guys can see them, because I don't like how this graph looks up. Okay, that's our first one up above. It's our second one like that. Yes. We're just testing points. So in this case, we want to just test them. I'll be probably giving you these to test out, but I'm looking around where my intercept is. So I'm going to test back 3, 1, 2, -3, because it's close to this, right? So I'm going to test -3, and this -3 gives me 7. And then I'm going to go, let's go a little bit further down to the right. Let's see what it does. Does it curve back up, or does it taper off? It should taper off. So if I go 5, 1, 2, 3, 4, 5, it's at 0.5. So we're looking at it curving down. And then at -4, I'm going to go -5, which is backside a little bit. And just to keep, right? So I'm back here. This is going down -7 because I want to test my points. Does it exist above or below?
Below.
Right, it exists below. So we want to make sure we're going to kind of mimic that. Does that make sense? So we're just testing. I'm going to probably give you guys these points to use. And then with those, you're going to be able to graph those. Does that make sense? Yes. Yeah, I'll probably give you them. But if you wanted to, the more plots, the more that you try, the better accurate graph you're going to get. Does that make sense? So I think I'm just going to give you them. We haven't spent that much time on it. And if you have a team test on this tomorrow, I don't want to be too hectic on it. Yes. For
-7.
Yeah, this is -3, 5, -5, and -8. 7.7. Oh, this is going to go back. So looking at my -5, yeah, -5 is going to give me back down -7. Yeah, mine's a little bit, I can graph on, but you guys can see it 1, 2, 3, 4, 5, 6, and then mine is actually right here on the board. So this is at -7. So we're just plotting points. The next one should be a little bit nicer when we graph it. Comprendo? Here we go. Copy this one down below. This is one that I actually like. This is something I actually like. Okay? I think it's a good one to give you. I don't think it's too difficult. Can this be factored? No. Not going to be factorable, so we're going to leave it factored, unfactored. We got to be able to determine the intercepts. That's a step number 2, just to see if they cross the x and y axis. How do we determine those? 0, right? Y-intercept is setting y equal to 0. X-intercept setting x equal to 0.
Wait, I'm sorry. Repeat that one more time.
To solve for an x-intercept, you got to set y equal to 0. Y-intercept, you're setting x equal to 0. It's opposite. It's opposites. If we plug in for y-intercept, 0 is going to give us x plus 6, x minus 3. The bottom's going to go away because we're going to multiply it by both sides. That means x is going to be equal to, so our intercept is going to be at negative 6. X-intercept or y-intercept, we're going to set our x's equal to 0. Y is going to be equal to what? 6 over negative 3 or negative 2. If we had to graph those 2 points, we can write them in our chart right here. It would just be 0, negative 2 is one of them. So 0, negative 2 for a y-intercept. And then negative 6, 0 would be the other one. So in back 6, 1, 2, 3, 4, 5. These would be our intercepts. These would be our intercepts for them. Horizontal, go ahead, look at the degree. Longest, biggest degree. If we do this, we're going to go ahead and look at our vertical asymptote. Vertical asymptotes comes from the bottom. That means x is going to be equal to 3. So I'm going to go to 3, 1, 2. Do I need to make that line thicker for you guys? 3. Solving it for 0 gives us 3.
So are you just using like the points that you used at the top?
Yeah. For the points so far, these are just intercept points. Yeah, these are just intercept points. Horizontal, we got to look at what? It's the same. So we look at x to the first, x to the first. So we got to look at what? Leading coefficient, which is 1 over 1, or just 1.
So when you do, so for the slant, is it if the coefficients are the same too?
No.
Oh wait.
Coefficient is going to be larger. You'll see on the next one because we're going to do a practice one of these. Can you kind of see a rough idea of what it's supposed to look like? Sure. If we're looking at this one, because I already have these 2 points down here, shouldn't these two connect kind of sort of like this? Right? The closer they get to it, the more depths they get. So we can kind of graph them that way. We're going to give you guys accurate more points to graph, but okay. The next thing we're going to do is we're going to test our points now. So we're going to look at the left-hand side of this one, so we'll do 1 over 1, 2. We'll look at an intercept of 2. So we'll try 2 right here. It should give us more negative. This is 3. We'll try 4 to see what if it exists on the top or bottom. And this is 4, 5, 6, 7. Let's do 8. Let's say 4 and 8. So these are potential ones I can give to you. This one's definitely off your guys' page, so if I had to do just this, we're gonna, yeah, the top and bottom. So if I had to graph, if I had to do some of these for you guys. So I'm kind of eliminating this real quick. If I had to plug this 2 in, it would be y is equal to 2 plus 6, 2 minus 3. This would give me 8 over negative 1, or just what? Negative 8. So I'm going to put negative 8 here. So at 2, we should be down negative 8. So mine's a little bit off my graph. So if I had to graph these 2 points.
So can it not pass that line?
It can't pass this side. Asymptote you cannot cross. Okay. If we had a graph 4, so this is 1 over on the right-hand side, so we're either going to look on the top or bottom of this. If we plug in 4 into our equation, we're going to get 4 plus 6 over 4 minus 3. It's going to give us 1 on the bottom, 10 on the top, so it's going to be at 4, 10. So 1, 2, 3, 4, 5, 6, it's going to be super up here. And then if we do 8, y is equal to 8, so 8 plus 6 over 8 minus 3. 5 over, was it 14? So it's going to be at 2 something. 2.8. So I know you guys can't see it, but I wrote, so this would be at 4, 10, 8, 2.8. So we're going to go to 4, 5, 6, 7, 8. It's going to be at 2.8, somewhere down here. And we know it's going to mimic it, so we know it's going to come down with that.
So there's only ever 2 points for that.
You can do more. You can do 5, you can do 6, you can do 8, you can do 10. The more points you do, the easier it is going to be to graph it. So if you want to do more points, absolutely.
Do we have to?
410 was 8. So I plugged in 8 into my function and got 410 over 5, which is 8 is 2.8. So all I do is I plugged it in. So at 8, 1, 2, 3, 4, 5, 6, 7, 8 is going to go up to 1, 2.8. So it should be crossing down here. Right. Is this easy or hard? Right, finding the intercepts, finding the asymptotes, those are like half your points already. Being able to plug in your values, that's it. Cool? Okay, let's try a more trickier one. We're going to try all different cases. The definition of it? We don't have an S. We don't have an S for that. Even if I write it down, I could potentially give you an S, but it's not going to always be the case. Can she go? Yeah, can you go? Yeah. I was like, can she go to the restroom? Dang, you're an advocate, man. Sorry, that sounded super weird to me. Okay, here we go. Now, with this one, can we factor? Let's factor it. We're going to factor the top. 1 multiplies to 7, adds up to 8, is going to be?
Oh, what was it? It was x squared plus 8x.
X squared minus 8x.
Here, I'll just do this. Here. You guys all freaking out. Here we go. Is that better?
Yeah. Thank
No worries. Got to find the x and y intercept. In this case, setting y equal to 0. It's going to be our first case.
What happens if it's like x plus 2 times x minus 7 over x plus 2? Do they cancel out or no?
Yeah, there's a special thing that happens when we get that, but we're not going to. You're jumping in too much.
Would we just be able to set those all equal to 0?
Right. If they're already set equal to 0 to solve for the intercept, you can just determine those. That's exactly what we do it for. That's a reason why we do factor, is when we set them, when we factor them, and we find an x-intercept or a y-intercept for this case, it easily tells us what those values are. Good going. Good going. I like it. I like it. Y is equal to 0. That means we're going to set our equation equal to 0. So 0, I'm just going to do this. 0 right here. Essentially what we get is we get the top equal to 0. That tells me my two intercepts are going to be what? 7 and 1. It is possible to have two intercepts, and you'll see that right now. So I'm going to go over 7. 1, 2, 3, 4, 5, 6, 7 is right here. And I'm going to get at 1 as well. It's going to kind of be a funky looking graph, okay? Yes.
Are we going to ignore the x minus 2?
If you multiply this out correctly, if you do this correctly, and we multiply both sides by x minus 2, x minus 2 times 0 just goes away. So whenever you're looking for the y-intercept, essentially, most cases, the bottom denominator will automatically get rid of it. The next one we're going to do is when x is equal to 0. If x is equal to 0, we're going to get y is equal to, I'll tell you right now, we're going to get 7 over negative 2, or negative 3.5. So this doesn't help us graph it at all. We got to be able to keep on going and graphing with this. Vertical asymptote comes from where? Bottom. So it's going to come from x is equal to 2. Horizontal. What's going to happen with our horizontal? Look at the exponents. What do we have with the exponents for this one? We have large over small. So in this case, because I have large over small, so we're going to look at x squared to x to the first, so larger over smaller. That means what I have to do? Long division. So this would be inside would be negative 8, 7, and 1. 2 on the outside. Okay, I feel like I'm not giving myself enough room. 2 on the outside, 1, negative 8, and 7. Dropping down that first one, we're going to get 1, 2, negative 6, negative 12, and I think this comes out to 3, 5, negative 5. We only care about the first two. This will give me x minus 6. This is my slant. So we do not have a horizontal, but we have a slant asymptote at y is equal to x minus 6. Let's graph these two. Vertical asymptote at 2. Horizontal asymptote at x minus 6. So this tells me I got to go down 6. 1, 2, 3, 4, 5, 6. Up 1. I'm sorry? No, slant asymptote. Slant asymptote. I'm going to give you guys some test points because we're going to test around here. See what it looks like. We already have these two. We already have the blue and red dot. So we're going to try one a little bit out more. So we'll try it at negative 2. So I'll give you these. Yes. This is y equals mx plus b. So in this case, because on my slant, I'm going to go down 6 to my intercepts. 1, 2, 3, 4, 5. I'll bring them down by 1. 1, 2, 3, 4, 5, 6. Up 1, over 1. Up 1, over 1.
And that's if
It's a
the
slant.
exponent
Is larger than the one on the bottom. Okay, we're going to test this one. We're going to test -2. Then we're going to test, let's try 3. We'll try 4. And we'll try 6. Okay, we're going to test those ones. I'll give you the answers if you guys do not want to test these, so give you guys more time. I'm sorry? Okay. I'm sorry? The bottom denominator, right, is always opposite, so we always got to use the backside. So at -2, we are gaining 18 to 5. 3, we are getting -8. Hello, hello. How are you? No worries. You're my guest.
We're checking for the monitors that came down.
Oh.
Do you have monitors up here, TV?
Oh, yeah, it was up here. It's already covered. It's gone. Yeah.
Check and see if it's
Yeah. Give me 1 second.
Sure.
Here you guys go. It's going to look something like this. Homework problems really quick. Hold on. Give me a second. Give me 3 of them. Try this little slant one. There you guys go.
No.
My hair is a mess. I don't even care. Bye, Miss Regular.
Bye, guys. You guys have a good day.
You too.
Right here.
That's where it was.
Yeah. Is it all right to come in and smooth
Yeah, Joe.
right now? Would it be all right?
I'll have a 3rd period. It's my Robbie's class. Can you guys come back and have it? 4th or 5th period?
What time?
4th period is going at 4th period. Not 3rd period.
Okay.
Oh, my
4th
3rd
period
period.
is 11:24 to 12:18.
11:24. Okay.
Okay. So, 4th period would work out way better.
Thank you.
Thank you very much.
Oh, I love you.
Bridget, can you turn on the light? Thank you.
Of course you did.
That's a good excuse to read my stuff.
Wake up in this country.
That's all I do. I took a shower last night. Yeah. Sat down.
We got your homework.
Are you guys trick or treating around this area?
No, and we're gonna do it the backside.
I was gonna say, don't go to like you don't know that. But my house is probably way too scary for you now.
Connor, don't you want one? Connor's too tired. Connor, don't you want one? Connor, don't you want one?
He doesn't even know.
We'll look at it.
Who are you?
I'm a scary twin with Ari. We did for Ari and I.
Yeah, that's cool.
I'm very happy.
Mr. Aguilar,
What's up?
look at him. This guy has to. You know I'm not surprised.
There you guys go. Do these D-Nows, one more count.
On Halloween, Mr. Aguilar, are you crazy?
Mr. Aguilar, can I go to the restroom?
How's it going? Good. Did you get questions to be 103?
I should do one. Only some of them. Only some of them.
Alright, I'll see you later.
Sorry.
Hey, Troy. You sound like just like a mom.
Oh! You got your mom.
Really called you a pirate.
Hi.
Hey. Sit down.
I wasn't late. I was late right here. I just had to get some tape. I went outside.
Do now. Let's go.
It's cold. Oh, I need to go home.
So basically, you're always saying, school.
No, that's what
Yeah.
That's me right now. Oh, I need to help me do a square one right there.
Party breath?
Let's see your
Party breath?
Let's have different height. For, I thought that was for rectangle. Oh, okay.
No, it's not going to sense if you get the.
Oh, you gotta get down. Oh, gotcha.
Mr. I gotta work sharp in there. Hey, what is it? He's ripping. He's ripping.
I think I have like one compliment.
You hear me? I hear everything. I know. Do not disturb me. No, I'm saying she had a whole time. You're asking me.
This is me.
Got to like.
Oh, right here.
Hey, Troy. Hey, send me your minus 17, right?
again? I was taking my test.
I don't think I got it.
From a 10.
Oh God. Hey, who was the play? Maybe my see, I can play with you. Everybody.
Hey,
Except me.
Right.